3, which is the black hole lab. So in this lab, I use my email in order to generate a unique trajectory of a star orbiting around a black hole. And then I use GlowScript in order to determine the net force acting on the star, as well as to find the mass of the black hole. The fundamental principles I used in this lab were the momentum principle, which states that the net force is equal to the change in momentum over the change in time, as well as Newton's law of universal gravitation, which I have the equation for that on the right side. I used that in order to find the mass after I calculated the net forces. I also used the perpendicular and parallel components of the change in momentum. The parallel component describes how the magnitude of the momentum changes, while the perpendicular component tells us how the object's direction changes. Because F net equals dp over dt by the momentum principle, the perpendicular and parallel components are equivalent to the perpendicular and parallel components of the net force. On the right side, I show how I put these concepts into my code in order to find the net force. You can see on line 174 where I used Newton's second law / momentum principle in order to find F net, which is equal to dp over dt. And in the next lines, I use these equations on the left side in order to calculate dp dt parallel and perpendicular. And so these are the initial conditions that I used for my code. I used the gravitational constant, which is equal to 6.7 e to the negative 11. And then I used the mass of the star that we were given, which was 2.0 times 10 to the 30th. The seed I used was my email. And then delta t, which was equal to 1 day, I converted that into seconds, which was 86,400 seconds. And our starting time was at t equals 0. And so this is the code when it's running GlowScript. As you can see, the cyan arrow correlates to the parallel component of the net force. The magenta is the perpendicular component of net force, and the orange arrow is the total net force. And so these are just screenshots from my GlowScript model that I showed previously. And these are the results that I got from my code. So I used Newton's law of universal gravitation in order to calculate the mass of the black hole, and I just rearranged the equation in order to solve for the mass. And then I plugged that into my code in line 194. And so using that, I was able to calculate the mass of the black hole to be 1.40 times 10 to the 34th kilograms. And so possible sources of error in this code could be any possible errors with the computer trying to calculate the net forces. Also, we assumed that the black hole was not moving and that the net force was only from the black hole. If these assumptions were not true, then they would change our calculation of the net force and therefore change the calculation of the mass of the black hole. So now to answer the discussion questions. First, how does the net force differ from the rate of change in momentum? So by the momentum principle, we know that the net force is equal to the change in momentum over the change in time. However, they are different in what they describe. So the parallel and perpendicular components of the net force describe the forces that act on an object, but the perpendicular and parallel components of the change in momentum over change in time describe how the net forces cause an object's motion to change in magnitude and in direction. Is it possible to find the mass of a new black hole different from the original one? No, it would not be possible. If the orbital of the star does not change, then the net forces on the star also would not change, and therefore the black hole would have the same mass as the original black hole. And that's the end of my lab 3, and thank you so much for watching.